वीडियो एंड बहुत दिनों के बाद आज मैं लाइव वीडियो के साथ आप लोगों के साथ आ चुका हूँ और देखते हैं आज कौन कौन लाइव वीडियो में आ पाता है, आज कौन कौन लाइव वीडियो में जुड़ते हैं हमारे साथ और देखते हैं क्या क्या हो पाता है। तो बेसिकली आज के वीडियो में मैं कुछ चीज़ लेके डिस्कस करने वाला हूँ, कुछ चीज़ आप लोगों को समझाऊंगा, शायद आप लोगों को अच्छा लगेगा। तो चलिए समझाने से पहले मैं एक बार अपना जो सेटअप है वो एक बार सही कर लेता हूँ, क्योंकि मैं ये तो करने वाला हूँ, मतलब समझाने वाला हूँ आप लोगों को, तो थोड़ा बहुत सेटअप सही होना ज़रूरी है। तो एक बार मैं अपना पेन और मेरा जो नोटबुक है वो एक बार सेटअप कर लेता हूँ और आप लोग आइए, धीरे धीरे आइए, कोई बात नहीं, आप आते रहिए और एक सेकेंड। ओके, ये मिल गया। आज मैं बेसिकली आप लोगों को कुछ समझाऊंगा और मैं अपना Q&A सेशन भी रखा है इसको, तो अगर आप चाहे तो आप हमारे वीडियो के रिलेटेड कोई भी टॉपिक पूछ सकते हैं, या फिर अगर आप चाहे तो मुझसे भी कुछ भी पूछ सकते हैं आप लोग, क्योंकि ये लाइव वीडियो है, ये लाइव Q&A वीडियो है, तो आप कुछ भी पूछ सकते हैं, कुछ भी मतलब कुछ भी पूछ सकते हैं आप लोग। ठीक है, तो एक बार मैं अपना लाइव शेयर कर देता हूँ तो थोड़ा सा हेल्प हो जाएगा। ओके, मैं अपना जो लाइव वीडियो था वो शेयर कर चुका हूँ और शायद कोई जुड़ चुका है हमारे साथ, तो हेलो। और मैं आज थोड़ा टॉपिक डिस्कस कर लेता हूँ, ठीक है, और आप पूछिएगा कोई भी क्वेश्चन तो मैं उसका आंसर देता रहूँगा समझाने के साथ साथ, ठीक है। तो सबसे पहले समझ लेते हैं कि एलसी सर्किट क्या होता है, ठीक है। कुछ सर्किट लेके डिस्कस करूँगा और कुछ टॉपिक लेके भी डिस्कस करूँगा, तो आपको शायद अच्छा लगेगा ये वीडियो। तो देखिए, मैं अपने बैक कैमरे में आ गया। ये हमारा एक डायरी का पेज है, ये वाइट वाला पेज है, तो देख सकते हैं यहाँ पे मैं थोड़ा सा लिख लेता हूँ पहले, ठीक है। ये फोकस होने नहीं हो रहा, ठीक है। तो आज हम पढ़ेंगे एलसी सर्किट। तो क्या होता है ये एलसी सर्किट? थैंक यू, हेलो हेलो। तो दो जन लाइक किए हैं, थैंक यू, उसके लिए वेरी वेरी थैंक यू। और आज 22 लोग जुड़ चुके हैं। और व्हिच लैंग्वेज इज you need, which language, please comment down below. Otherwise I will talk in that language, Hindi or English. So this is LC circuit, right? So what is the LC circuit means? Basically we know L means inductance, ठीक है। Okay, so this is focusing issue. So L is inductance, and what is C? C for capacitance. Okay, inductance and capacitance. And why we should use this one? So you know, here it is like our AC signal. Okay, it is sine wave AC signal. Okay, my drawing is not very good, so please consider it. So it is sine wave AC signal, right? So here is the peak. Okay, here is the voltage peak. Suppose this is the zero value and this is 5 volt, this is 5 volt AC signal. Okay, and this one is plus 5 volt, and now here is 0 volt and here is negative 5 volt, right? There is the peak, up down up down up down, this is. So we need to rectify this one and we have to make this one in a DC format. DC format. So you will know, so when we have to convert AC to DC, we use full bridge rectifier. And what is full bridge rectifier? Full bridge rectifier is a bunch of diodes. Okay, so how can you make it? Basically, you have to connect 4 diodes, right? My drawing is so bad, so don't worry, I am trying to improve my drawings. So something like that, we have to connect that diodes, right? There is the full bridge rectifier, and this is full bridge rectifier. And after passing this AC current through the full bridge rectifier over here, we will get the DC current, which is even it has the pulses, right? That is like yeah, this is positive. Okay, this one is positive and this one is negative, right? So now this is here, the graph will be like this, like something like this. Okay, something like this. Sorry, this is not the accurate, so I draw here, or yes, something like this, right? They are all positive positive, or something like this is voltage peak, or this is 0, right? So this is the peak. And you have to know what use LC circuit, right? So basically we have to make this graph into this graph. We have to get this graph, this line graph, right? So we need this graph. So how we will get this graph? So this is for the LC circuit. So here I am going to discuss over here, right? So basically we connect, here is the DC source, right? My mobile is not focusing, right? So it is the DC source. I suppose this one is 5 volt DC. Okay, so here is 2 wires, here is positive and here is negative. Oh wait, I have different color pen, that will be helpful for understanding. So this one is positive, right? This one is positive, which is red, and this one is negative, which is black, right? So we have to connect here a LC circuit. So LC means, first of all it will come the inductance, and then it will come the capacitance. Okay, the capacitance. So now we will add the inductor, something like this, right? So basically what is the inductor does? Basically it will block the AC current, AC voltage it will block, and passes the DC voltage forward. So after forwarding the DC voltage over here, we have to connect here a capacitor. Okay, voltage rated capacitor, which is plus minus, that is plus minus, sorry, I changed the polarity, and this will be blasted, but yes, this is now okay. So suppose here we are using a capacitor, and now everything is arranged. So here what graph we will get? Let's see. We will get this graph, right? This graph we will get. This is 5 volt peak. This is the LC circuit. Whenever you using a whenever you will make a power supply for your lab bench power supply, or your amplifier or something which need a DC power descent, then you use this circuit. So I draw here the diagram. I'm drawing here the total diagram, right? So you can take a screenshot or something. So this is basically the AC source, right? This is basically the AC source, which is in my country, in India, it is 220 volt AC. Okay, and it is 50 hertz. So I am using a core transformer, iron core transformer, and it is making 0 12 volt of AC current, right? It is 12 volt AC current. Now we have to pass this current through a full bridge rectifier. So when we pass this AC current through a full bridge rectifier, then it will become a DC current. So I am going to show the DC current using marker pen. This is positive, and here in the bottom side, here it is negative, right? And here it is, you can see this is the graph over here, right? This is the graph over here, sine wave, and this is the graph over here. This is full bridge rectifier, and after full bridge rectifier, this graph should be like this. And after this, we have to add this LC circuit, right? This LC circuit. So add the LC circuit over here, LC, that is. And after adding the LC circuit, you will get a simple DC 12 volt peak graph, and this is the pure DC form. And here it is the transformer, and is the full bridge rectifier, the LC circuit, and total this is the DC power supply. And if you want to make it a variable, then you can use here a multiple transformer, which has a basically, suppose this is a transformer like okay, right? So here in this point we have to give 220 volt AC, or this is why which your country is rated by, and 50 hertz in our country. And here this transformer has one neutral and some points, that is like point 1.5 volt and 2 volt, 5 volt, 9 volt, 12 volt, and 19 volt, something like this. And you have to use a rotary switch, which is basically connects the common and one of these pins. So basically you connect this all, and the neutral and the output of the switch will be the voltage rating, and then you will use the full bridge rectifier and the LC circuit. That will be a pure DC adapter. So here is the basically the how the LC circuit works. And next, yeah, I was not look at the comment section, but yes, this is the LC circuit I described just now. This is total LC circuit, and there is no mathematics, no calculations. A new video will be come by it. Thank you. Hello from Malaysia. Thank you. Hello from India. And okay, so this was the LC circuit. Okay, so now I am going to tell you how a SMPS work. Basically SMPS is everywhere, right? Switch mode power supply, which is basically from your mobile travel adapter to your this type of this type of laptop adapter charger. So I am going to show you how these adapters work. Okay, hello Muhammad Ahid, I am very good. I am fine. How are you? Okay, so let's discuss this. Okay, so how the SMPS works, right? Here it is a new page, here is the old page, right? So here I am going to show you the engineering of SMPS, right? Okay, those who want to ask me any question, you can ask me, right? And I am going to discuss this one, so please ask me question. And so I'm discussing this one, but you can ask me question if you want. So SMPS, how it is work? Basically, we have in our country 220 volt AC, which is in 50 hertz, right? And here, first of all, we have to pass this AC current through a filter circuit, and then a full bridge rectifier, and then in a IC. This IC will generate PWM signal, which is square wave signal. This circuit which will generate, and the DC current will go through here, and this generated PWM signal will feed into a mini transformer, which is basically a ferrite core transformer, and these transformers are working between almost like high frequency. Okay, so basically uh, here it is the IC, okay, IC which is producing PWM signal. And then for this transformer we have to use a transistor, right? We have to use a transistor, so T1, and we have to feed this transistor through the IC, and this pulsation will feed into the transformer. This is transformer which is ferrite core transformer, and after the transformer it will become the DC low voltage, right? And here is a feedback circuit, which is basically a something like, it is called optocoupler. Opto, maybe my spelling is wrong, and this is called optocoupler. This is basically a photo transistor, right? So here is a LED light or something, and here is a transistor. So this is the optocoupler, right? So we feed the transformer voltage into the optocoupler, and this feedback will get into the PWM IC, and that's all. This is the basic circuit of a SMPS. So I think you will understand this one. So what is your question? Basically, I am today going to basically I do this live session because of I just want to my English is so bad, right? I just want to do it with live, and I mean I just want to do a live session which is Q&A also, so you can ask me questions. And where are you from, you can also you can write in the comment section. My English is too poor, and I will make videos. I don't have time so much. I did not getting any time, so I cannot making the videos. So here I have a book, right? You can see here I have a book. So from this book we have many projects, and I am going to discuss over and over time. Okay, and I will teach you something, maybe you will like it. And you know, obviously you know my power bank which I was made before. See, this is functional, this is fully charged right now. Okay, and so I um just teaches you the AC circuit and the SMPS's working principle, right? So let's talk about how these inverter things work, right? If you don't have any question, then I will teach you something that will help with your projects. And so, do you have any question regarding past lessons? Maybe not. So let's discuss other thing, right? So basically now I am going to discuss what is a inverter circuit. Inverter, what is a inverter? Inverter is nothing but a device. Okay, no, I am not starting here a definition like video, right? So basically I am going to tell you that inverter is basically a device which is converting the DC voltage to the AC voltage. And why we need AC voltage? As you know, I mean, obviously our home is full of AC voltage, right? Our all appliances are AC voltage rated. Like you have a fan, you have a light, everything runs on AC voltage. So if you have the DC voltage, which is the main source, the main source of DC voltage may be the battery. I am telling maybe because may you have some other thing to have the DC, right? So I have only source which is battery. And when it is power cut or the load shedding, then we don't have the AC current, but we have to run our fan, light, and charge our mobile phone and other electronic devices. So we need a inverter or a converter which convert DC into AC, right? So why, so how these inverters are made and how it work, let's discuss this. Basically, if you know about transformers, like transformers, then you will know if you add a high voltage here, so you will get low voltage here according to the ratio of that ratio of turns and everything, coil turn ratio and everything. So here we giving this 220 volt, and here we will get 6 volt or 12 volt, which is in AC form, right? But we have to convert 12 volt into 220 volt. That how it is possible. Then we have to know about the circuit, which is oscillator circuit. So we can use a MOSFET which can deliver a high ampere, okay, high ampere over its pins and can turn a transformer on, by which we can just feed our transformer through a MOSFET, and thus MOSFET will work through a MOSFET. This is called a MOSFET driver, right? This is a basically IC, maybe a IC or basically a bunch of circuits, right? So this is basically a MOSFET driver, and we feed basically the main power which is from battery, and then it will go through the capacitors, right? Capacitors, and then it will go, then, and yes, obviously it go through the fuse, right? Otherwise it will blow the circuit. It will go the fuse, and then it will feed into the IC which drives the MOSFET, right? And this is the basically main engineering, right? So here is the MOSFET and the transformer, here it all. And in case of reversing, I mean recharging that battery. Then the MOSFETs are made that way that the MOSFETs are working as a diode and a MOSFET. This is depending upon some conditions which nowadays the companies are making, right? So basically I'm just discussing something on where are you from. You can ask me any question. This is basically Q&A video, and yes, you can ask me anything if which you want. And thank you. Hello Hitartho, hello. mm, I'm sick, I'm not well, so my nose are running continuously. So you can ask me any question regarding my channel, regarding my projects and everything. Do you liking my website which I made earlier? And in this website I am posting articles, like many articles. I will post many articles, but I currently I have only one article which posted, and I am just discussing some topics and some theories, right? And some theories. And wait, I will show you some, maybe his item, which is this one. This is basically a which is light, which is maybe damaged, because here is the main problem is load shedding. And if you know, um, I am running my YouTube channel since 2022. So how can I post more videos? I mean, I don't have any ideas. You can give me idea, and that will help me, right? So basically I just I'm just discussing everything. So let's talk about a basically something like booster circuit. Let's talk about the booster circuit. This will be interesting, right? Sorry, my nose is running all time, 24 hours. Okay, so here in the page of my diary, and here, okay, some focus issues, sorry for that. And yes, here's the booster circuit, voltage booster basically, right? Booster voltage. And okay, Hitartho, I definitely will make that video about how Thomas Edison will make bulb, right? Okay, definitely I will make. Thank you for the suggestion. And let's talk about the booster voltage circuit. Basically, we all know, maybe you know, that inductor has a magical property, which is when you connect a battery through it, right? Like this and like that. Here is a push switch. I am named it like P, right? And here is push switch, and this whenever you click the switch, the current will flow through the inductance, through the inductor, and make and when you open the circuit, when you open this switch, then this inductor will flow a high voltage between them, right? So this is a basically booster circuit model. So here is a battery, right? Basically this is the symbol of a battery, and we will make a inductor, something like that. Inductor, you can make inductors very easily, right? You can take them from your old relay, and also from mobile chargers, and from all other SMPs or that kind of things, right? So here it is. So basically I am just drawing a battery, right? Just like this, and this is the positive and this is the negative. So connect the negative over here and connect a push switch over P, so over here, right? Yes, this is the push switch. And after that we have to connect a diode, which is the work of, what is the work of a diode? It basically flows current one way. Basically this is a diode, this is like a one way valve, right? This is basically a one way valve, and this is the positive and negative, and here current flows and here it comes, but not flow that backward way, right? So basically we have connected a diode, and here's continuation of this one. And after rapid clicking of this switch, this diode and this inductor will I mean this will generate voltage, but this will like this one, right? Like this one, this one, this one, and like that, but this isn't flow. So we can use a capacitor for that. Capacitor will store charges. That's why you will get a, after something like 1500 of clicks, and you will get here, if you add here a 120 volt and something like 1000 microfarad capacitor, then you will get almost 90 to 100 volt, right? 90 volt to 100 volt. And yes, this is very dangerous voltage. Don't touch it with your bare hand, it will shock you. And please don't use higher voltage than that, because this will even dangerous. And yes, um, this is the switching mode basically. So in case of buck converters, which is basically a buck converter, sorry, this is not looking good, sorry. Buck converter is okay. Buck converter. My nose are flowing all the time like a 1 horsepower motor. So this is the buck converter, which basically boost voltage, something like, if you give here 3.7 volt, and you will get over here 24 to 30 volt. This is the basically the things. So sorry, my nose is running every time. So here it is the concept. So here is the switching system. Here we can use a transistor or a MOSFET for switching is automatically. So this circuit and this video is present in my YouTube channel, you can watch this. And here we can use a toroidal inductor, which have basically modified, and it has two main loop and a middle loop, right? And a middle loop. And here it is all, here we will connect the positive sign and the transistor and a resistor and all the components, and it will be in working condition. And here I am going to give you a, I mean, stupid idea, but you don't have to do this, right? So over here, this is the battery pack. If you want more current and more voltage, you can use this battery, these capacitors, like a series capacitor bank. Just connect your capacitors, there is a positive and negative. Just connect your capacitors, like here is the positive negative, and positive negative, just like that. Connect that, and the voltage will be same, like 120 volt, and the capacitance will be increased. It is all about the calculations and all the things, so it will increase, right? So here I suppose here it will increase to 2000 volt, right? This is not correct, sorry, microfarad. This is not correct, right? But yes, something like that will happen. And after that, you will get a massive ampere and a high voltage. So if you have a big capacitor bank, then you can obviously charge your mobile or light up a LED bulb, maybe. And let's talk about how those shaking type of चार्जर्स वर्क, राइट? शेकिंग टॉर्च, जो हिंदी में कहते हैं हिलाने वाला टॉर्च। एक ऐसा टॉर्च होता है जिसको हिलाने से इलेक्ट्रिसिटी जनरेट होता है। तो बेसिकली इट इज़ द कॉन्सेप्ट, दिस द टॉर्च, राइट? हेयर इट इज़ द टॉर्च, हेयर इज़ द फोकसिंग जो होता है वो, एंड दिस इज़ द बल्ब, here it is the LED bulb, and we have connect a mini magnet, right? We will put a mini magnet into there, mini magnet, right? Like this, right? Like this, and we will wrap bunch of wire, enamel coated copper wire over here, and when you shake this torch like that, right? When you shake this torch like that, and here I have another thing which you can also shake, you can hear the sound. Yes, I can also make this one from this whitener. So basically when you shake it, the magnet will up and down and change the magnetic field, generating AC voltage. Then the AC voltage is converted into DC through a full bridge rectifier, and for charge the internal, so we will use a super cap. It is basically a component which is basically capacitor, right? Which is mostly 200 farad, something like that, and the voltage is so low to 1.2 volt or something like that. So we need 3 volt or 2.5 volt for run a single LED light, right? So we will use a series capacitor and full bridge rectifier to the capacitor, then here to the LED light. That is all the concept, and I will create this project. I don't know if this will work or not, I don't know, okay, but yes, I will definitely make it. And if you want to know more, you can comment down below, right? So how was this project? Comment below. Okay, so let's talk about something else, maybe. So let me find which thing I can just talk to you. I mean, which thing? My English is too poor. Okay, so that is why I am talking like that. Okay, so here you can see, wait, here you can see basically, okay, here you can see, here is a blower, is a blower fan, and maybe this will help. No, this is not helping, that this is a blower and my light is blown, so my room is dark, right? So this is a blower basically. It just see, just like that, right? Okay, wait, maybe yes, this is okay. So basically a blower, and here it is the back side, and yes, this is the front side. When I powered it with 24 volt, yes, it is run by 24 volt, and it rotate like that and sucks air from there and throw air from here. that is all. And yes, it can flow many years, but I mean I mean more years. And you can use a AC machine by using this type of blowers. Just connect a radiator coil over here, right? Over here, just connect a radiator coil, and you will get a cool air from this side. Maybe I will make something like a air condition or something in future. So if you have any suggestion for me, you can comment down below, right? Where are you from? You are watching, you can comment down below. This this may be a Q&A video, but nobody asked me any question, so I did not answer any question, right? Yes, one of you asked me a question that how am I? Yes, I'm good. That is grateful. And yes, uh, दो तीन लोग तो आ रहे हैं. So what do you want to see, and what do you basically want to learn from me? What do you want to what do you want me to teach you, right? You can just comment down below your topic, and I will discuss on it. And yes, some video topics are in my mind, so I will discuss them. But basically, for now, I am just going to my laptop's display and showing you something. We'll show you something. Wait, I'll show you something. Okay, so basically how my laptop is turning on, right? This is how my laptop is turning on. And okay, wait for some time. After turning it on, I will basically show you a software which is called Easy EDA. Now this is not sponsored. This I am using this from like 2 or 3 years. Yes, and this is quite good. Software is quite good. And yes, this is intelligent software. Wait, yes, this is the software, right? See, this is the software. This is called Easy EDA. This is the software from the GLC PCB company. And here it is the best thing, that project. And I just created some projects over here. You can see here, like that. You can see here I just created a project, and that's it. And here is the SMPS, maybe that one. Yes, just I was looking for some ideas and something. So ACDC modular, maybe. Okay, yes, maybe this. Yes, this one is basically a this one is basically a inverter, right? So please rotate your mobile, so I will show you. Okay, maybe you can see the display, right? Okay, so here it is. The okay, so no, my mobile is showing something wrong. Okay, so basically, see, here is the uh, battery connector, right? This is the 12-volt input, and here is the inductor and the capacitor and something, all of the things. Here is the 555 timer IC, right here, over here. 555 timer IC, and I just designed this full setup, and maybe this video will come. Here is the BC547 NPN transistor, which is basically, this circuit basically uses as the MOSFET driver. There is the two MOSFET, which is IRFZ44N, the N-type MOSFET, and that 3 points will feed into the transformer. Wait, here maybe I can use a transformer or something. Here you can see here many more of the things, so maybe we can use a transformer over here. Okay, so instead of this one we can use obviously a 12-volt jack like that, connector pin or something like other thing. Okay, so that's it. This is the basically inverter circuit which I just designed, right? And maybe some other project will be there. Okay, no, I don't have any project, so let's find out more project. And yes, if you can you tell me here what is the problem over the circuit, because I just made this circuit and just blow up. It just blown up, right? But I don't know why this happened, but I'm not expecting that. But yes, this happened. This IC basically matlab damaged. Every time I changed it 3 times, but every time it damaged. Okay, then you can basically convert this whole thing in a PCB. So I don't have internet right now, so I cannot show you that. But yes, you can see over here I saved a yes, PCB. Yes, this one I showed maybe that way. I just created this one, right? Okay, I just created this one, and this is basically a normal prototype. This is not functional. Okay, so this is the one layer PCB which I made, and you can obviously put capacitor, resistant and battery over here and something like that. You can make your own PCB board. I just have to create a PCB board for this one. Okay, for this but I don't have internet right now, and my laptop has this difficulty that here is the Wi-Fi adapter is gone. And if you have the any solution, if you have any solution, please comment down below. Okay, so here the Wi-Fi signal is gone. I mean the adapter showing it shows the adapter, but it is gone. I don't know why. So this is the problem basically. And here in the software everything you will need. So here's the component library, here everything. So if you don't have that item which is the if you have any if you need any item which is don't have here, so you can just search over here in the filter, and you can uh, just take it from the library, right? That's it, the whole thing. And we are connected with now one people. Okay, so I'm just ending this live over here. Thank you for connecting with me. So bye bye.